Did you know it's impossible to know both the position and momentum of a particle at the same time? This isn't because of some technological limitation or measuring error. It's a fundamental principle of quantum mechanics known as Heisenberg's uncertainty principle. It tells us that the more precisely we measure one property of a particle, the less precisely we can know the other. So in this fascinating world of quantum mechanics, certainty, it seems, is an illusion. Imagine two particles, light years apart, yet affecting each other's state instantly. Welcome to the fascinating world of quantum entanglement, where particles are so intimately linked that the state of one instantly influences the other, no matter the distance. This mind-bending phenomenon occurs when two or more particles interact in a way that the state of each particle cannot be described independently of the others, even when the particles are separated by a large distance. It's like having twins with a telepathic connection. This puzzled even Einstein, who famously called it spooky action at a distance. But as strange as it sounds, this is the reality of our quantum world. In quantum mechanics, distance is just another state of mind. Ever thought of walking through walls? Quantum particles do it all the time. In the realm of the very tiny, particles can play a trick on us called quantum tunneling. This is when particles like electrons pass through barriers that, according to the classical rules of physics, should be impenetrable. Think of it as a ball spontaneously jumping over a hill instead of rolling up and over. It defies our everyday logic, doesn't it? But that's the beauty of quantum mechanics. In the quantum world, obstacles are merely suggestions. Is light a wave or a particle? Well, why not both? Welcome to the world of wave-particle duality, the mind-bending quantum phenomenon that defies our everyday intuition. Here, every particle, whether it's light or an electron, behaves both as a particle and a wave. When observed, they appear as particles, localized at a single point. But when not under watch, they behave like waves, spread out and interfering with each other. This isn't a case of mistaken identity, but rather a fundamental aspect of quantum mechanics. It's as though nature herself is saying, why choose when you can be both? So in the quantum world, light doesn't need to decide whether it's a wave or a particle. In the realm of the tiny, identity crises are the norm. Ever been in two places at once? A quantum particle can. Welcome to the world of superposition. It's a principle that tells us a physical system, like an electron in an atom, can exist in all its theoretically possible states simultaneously. Imagine being asleep and awake at the same time, or both sitting and standing. That's a day in the life of a quantum particle. It's a bit like the ultimate form of multitasking. In quantum mechanics, multitasking takes on a whole new meaning.